Hey guys, so today we're going to take the knowledge that we have of inverse matrices and apply those to systems of equations. So this is one more way to solve systems of equations. If you remember back from like the very beginning of the year, we had like 2 or 3 different equations. We had to solve for x, solve for y, sometimes solve for z, and we had elimination, we had substitution. Now matrices are another way to solve those same problems. So our essential question is, how can you use a matrix to organize data? And our objectives are to solve systems of equations using matrix inverses and multiplication, and learn how to use matrix capabilities on a graphing calculator. So I've showed you some of that, but we'll do a little bit more and we'll discuss some more in class too. So solving. In order to solve some matrix equations, like you have a matrix times x equals another matrix. So A and B are both matrices. So in order to solve those, you need to multiply by the inverse of A to get rid of A, so you can get x by itself. And then you multiply inverses on both sides. So then x is the inverse of A times B. So you have to know how to find inverses in order to solve these. So what's the solution of this matrix equation? 5, 3, 3, 2 times x equals 1, negative 3. So we need to find the inverse, and to find the inverse, first we have to find our determinant. Remember, A inverse equals 1 over the determinant times, we switched A, D, negative B, negative C, A. Okay, so to find our determinant, the determinant is AD minus BC. So we're going to take and multiply 5 times 2, which is 10, minus 3 times 3 is 9. So our determinant is 1. So this one's actually kind of easy. So A inverse would be, we're going to switch 2 and 5 around and make both of the 3's be negative. Okay, if we were to take and multiply that times our matrix on the one side, what we get, you can do the math, but I will show you. What we get is our identity matrix. And anything times an identity is itself. So we have identity times x equals, now we have to multiply inverse matrix on the other side. 2, negative 3, negative 3, 5 times 1, negative 3. Okay, so in order to do this, we need to use our matrix and multiplication. So we're going to multiply top times bottom. So let's see, x is 2 times 1 is 2, plus negative 3 times negative 3 is 9. And then on the bottom, negative 3 times 1 is negative 3, plus 5 times negative 3 is negative 15. So our value of x is 11 and negative 18. So this is your solution. If x is 11, negative 18, if you were to plug that in right here, you would get 1, negative 3. Okay, let's go ahead and do this one too. So to find our determinant, to find our inverse, first we find our determinant. So we take AD minus BC, and that's 18 minus, and then 18, which is 0. So we get our determinant is 1 over 0, which we don't have a solution for. There's no solution for x. No solution, because we never divide by 0. That's terrible. Okay, I want you to go ahead and do these two, and you're going to discuss them with a partner. Vocabulary. You can write a system of equations as a matrix equation, AX equals B, using the coefficient matrix, a variable matrix, and a constant matrix. So what we do is we take all of our coefficients from each equation. So you'll see the coefficients 2 and 3 go in the first matrix, and 5 and negative 2 go in the first matrix, and top and bottom. And then we have one that has our variables. So our variables are x and y. And just go ahead and put them in alphabetical order. And then it equals whatever our solution equals. So let's go ahead and set up a couple of these. If the determinant of the matrix is 0, there is no solution, which we just learned. Okay, so this one we're just writing these matrix equations into, or these systems into a matrix equation. So we're going to take our coefficients. So our first matrix is our coefficient matrix. So I have 4 and 7, and I have -5 and 3. And then my variables are x and y, and then it equals whatever our system equals, 6 and 1. Pretty simple, right? Okay, let's go ahead and do this one. This one's a little more complicated. You need to make sure you keep things in order. So I'm actually going to start by rewriting this one first and have a, b, and c, and then it equals something. So this one I'm going to keep the same, 3a plus 5b minus 12c equals 6. This one, I have no a, so I'm going to write it as 0a plus 7b plus 2c equals 8. And this one, I have 5a. Now I need to move this 3c over to the other side, and I have no b, so 0b minus 3c equals 1. So now that I have them written all in an order, I can rewrite them as 3, 5, -12, 0, 7, 2, 5, 0, -3. My variables are a, b, and c, and then it equals 6, 8, and 1. Just like that. All right. Now when we solve a system of two equations, we set up the matrices, and then we do just what we did in the first one. We find the inverse, get the variables by themselves, multiply inverse on both sides. So let's go ahead and do this one. We're going to set this up as matrices. So 5, -4, 3, -2 times xy equals 4, 3. We need to find the inverse of this matrix. So we need to find 1 over our determinant is, let's see, -10 plus 12. So that's 1/2 times, switch our stuff around. This becomes positive, that becomes negative. Okay, so our inverse matrix is actually -1, 2, -3/2, and 5/2. Okay, now we're going to take and multiply that on both sides of the equation. So we're going to multiply it over here, multiply it over here. So we're just going to check it and make sure that it makes an inverse matrix. So let's see. So we make sure we put the inverse first. So -1, 2, -3/2, 5/2. We're going to multiply that times 5, -4, 3, -2. Make sure we get an identity matrix. So let's multiply those. We get this one by this one. That's -5 plus 6. That's good. Multiply by this one. That's 4 plus 4, minus 4. That one's good. And then we have -15 over 6 plus 15 over 6. That one's good. And -10, 20/2. -10 plus 9. So that one's good. So this makes an identity matrix, so we know that we did it right. Now the identity matrix goes first over here as well. So we're going to take -1, 2, -3/2, 5/2, and multiply that times 4, 3. So we multiply this by this. So let's see. That's -4 plus 6, which is 2 over this one by that one. That's -12/2, which is -6. And let's see, that's 15 halves plus 15 halves. So if we take negative 6 plus 15 halves, we get 3 halves. So our solution is 2 3 halves. So x is 2. Remember, x is on the top. So what we have left is x, y equals 2 3 halves. So x equals 2, y equals 3 halves. Isn't that cool? That's one more way that you can use to solve systems of equations. Okay, and then here's your lesson check. So I want you to take those 2 problems you did before, combine it with these 2 problems that you have right here, and discuss those with your partner. All right, and we're done. Have a great day.